The complex conjugates theorem, simply stated, means that you can't have just one single imaginary zero, or sometimes we call them complex zeros. You can't have just one. They always come in pairs. Their conjugates are also going to be zeros. Conjugates are kind of like opposites, but not always quite the same thing as what you might think of. And it turns out this is also true for irrational solutions as well. You can't have just one irrational solution. You'd also have its conjugate. So let's take a look at how we can use this to help answer a couple questions. So we're told that we have a fourth degree polynomial. Well, what that means is that I have four zeros, because remember, the degree also tells you how many solutions you'll have. And two of those zeros are 5i and 3 minus I. We want to know, or they want to know, what the other two solutions are. Well, because we just learned that complex numbers, imaginary numbers, can't be solo, they have to come in pairs, I know that my other two zeros are going to be found by taking the conjugates of what I have. So if 5i is a solution, then negative 5i is also going to be a solution. Negative 5i is the conjugate of positive 5i. So that in that case, it is just opposite. Just switch the sign around for those. When you have two terms, though, like this, 3 minus I, the conjugate is not the complete opposite. It's just the opposite of the middle sign. So the conjugate of 3 minus I is 3 plus I. So those represent all four zeros of this, and that's what we're talking about when we say we can't have just a single imaginary solution. They have to come with their conjugate. This can also lead us to some kind of interesting questions, like this one down here. Is it possible for a third degree polynomial to have three complex zeros? Why or why not? Well, as we just discussed, it's not going to be possible because you can't have just a single complex solution. So we could get two of them, two could be imaginary, but that leftover one wouldn't be able to be imaginary because it doesn't come with a pair, so it's not possible. You can also think of this in terms of end behavior, just as another way to think about these problems. If you have a third degree polynomial, its end behavior is going to either be one end up and one end down, like low to high, or if you have a negative leading coefficient, the end behavior would be described like that. But I mean, regardless, no matter what, at some point you've got to cross the x-axis at least once, and remember, any x-intercept is a real solution, so we'll have to have at least one real solution. The other two could be imaginary, but you can't have just one imaginary. It's got to come as pairs.